Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews, contracting, and on-site training. In this episode, I'm going to talk about something that I have been waiting a very long time to talk about, but we needed a compiler that finally supported it, and that is standard source location. This is a C++20 feature, and it is going to give us the ability to actually generate at compile time something that gives us the current file, line, function name, column, everything where we currently are in the code. And we're going to play with it. We're going to see what exactly we can expect from it, what the utility might be. And well, we can do this now because C++20's standard source location is officially supported in GCC. It is currently on the trunk. So I'm in my compiler supporter setup here, and we're able to try to dig into this with our standard source location. Now, the first thing we need to note that this is in fact in the source location header. So let's just go ahead and create one of these things and see what kind of values we get back from it. It seems these are all functions, not member values. Okay, so it seems that I don't have a file name, a function name, a line number, or a column available to me. So let's see what went wrong. So if I default construct one, it has unspecified value. That's clearly not what I wanted to do. It seems that there is a static member function that is called current that returns a new source location corresponding to location on the call site. This is very important. So this is const eval. So that means that this is something that must be called at compile time. That makes sense. And we didn't really look at what's being returned here. So this is a const expr const char star. Now, personally, I would have made this a const expr string view. To me, that would have made more sense, but I'm guessing this is one of these things where they don't want to have one header depend on another one in the standard. I'm not sure. So let's make this source location current. All right, we can see that in Compiler Explorer, this file is actually being compiled as example.cpp, and I'm getting the full function signature. That is incredibly interesting. Instead of getting the mangled name here, we're going to have to spend a little bit of time playing with that. And I see that it is on line 9, column 44. So that's line 9. Now the question is, why column 44? It seems to have been at the end here, at the end of this declaration. All right, so I'm actually getting, so it's not surprising that the const is dropped here because const of a value is not really part of the function signature in C++, and I've got my other videos on how function overloads work in C++. So that's not very surprising, but we do get a const char star here. So if I made this actually yeah, wow. Okay, so this could really provide a lot of very interesting information for some sort of our ability to do some sort of introspection or reflection kind of thing. This is definitely the start of interesting reflection code here. Now in this one, I'm going to make just a simple logging function here because I want to see what this does. Now this is a template function, and I'm going to print out whatever is available to me here. So I'm just going to create this thing by value, and it's going to be whatever the current value is. Now the question is whether it's going to give me the location for line 8 or if it's going to give me the location for the call point, and what kind of output it's going to give me for the fact that I've got a template function. Okay, so we can see that I'm actually getting the value for the call point here. So I'm getting line 19, location 22. So it was created effectively here. There was our parameter created for us at this site. So this could make making our logging functions like way easier without having to use a bunch of macro nonsense. So that's pretty cool. But we then also kind of want to see what happens if we call the source location inside of our template function. All right, so now we've called it here inside of our local function. I'm getting this for log, and then I'm doing the actual message here that I want. I'm going to comment this one out to reduce the amount of noise in our output. But it looks like we have been given just an extraordinary amount of useful information by GCC here. Now I'm guessing that this will vary somewhat depending on our compiler, but the fact that we actually get that this is a template because, well, we can infer that it is a template because it has this with t equals const char star, and then we're getting our debug message, or our location 1147 in the file called example.cpp. This is happening on line 11. This is pretty much what we would expect. Now we have to try a couple more things. What happens if we do this inside of a lambda inside of a function? Just going to do this immediately invoked lambda expression. I'm not going to return anything from it, but oh my goodness, this could really provide some very interesting information. Okay, I see that this is from a lambda that is declared inside of main on line 24. Line 24. That's really a lot of actually really useful information to us, both from a logging perspective and from the perspective of, like I said, potentially maybe doing this for some sort of introspection trickery. Not too sure yet how exactly that would work. We could actually, so this is a lambda that's, I'm gonna try. If I return this thing by value, then I'm going to be able to extract that information back out basically and know at a calling point what was available, what the function was at some calling point here. Let's see. So this did not change the declaration of our lambda here. I'm going to change this again and see if we can in any way get this to tell us that this is a lambda that's supposed to actually be returning a type of some sort. Okay, no, this is still just telling me that this is a lambda. Let's make it a lambda that takes an int and pass in some meaningless value. Okay, so now we see that this is a lambda that takes an int declared inside of main on line 24 is where this is happening in our example.cpp file. Interesting aside, now that we know that the name of this file is example.cpp, which we could have gotten with __ file _ previously, but this is still pretty handy. Really useful way of, like I said, of making log functions or perhaps doing some sort of rudimentary introspection of some sort. And a feature that I think is pretty darn awesome. I'm looking forward to our logging libraries and such taking advantage of this in C++20, and really glad to see that GCC has support for it now. So thank you for watching this episode of C++ Weekly.